We just went through why data science matters and some applications of it. In the rest of this week, we will look at the different stages of data science in a structured manner. Before we dive into that process, let us walk through a live example of how data science works in action. It is much more engaging to take real data sets and do your own analytics and come to your own conclusions. We will take the European soccer data set and perform analytics on it. Although how to build some parts of this example is not very clear to you now, by the end of this course, achieving similar things should be your goal. So let's go. By the end of this video, you will be able to talk about the big picture of data science through a soccer case study, generate statistics about a soccer dataset, summarize how data cleaning and correlations were applied to an existing dataset, recite the data visualization techniques employed in the study, explain how clustering similar groups and plotting these clusters helped the case study, and recall what was used to draw conclusions based on this data analysis. Each week in this course, we will work with a real data set and work on a case study. This week, we will be using an open data set from the popular site Kaggle. This European soccer database has more than 25,000 matches and more than 10,000 players for European professional soccer seasons from 2008 to 2016. Although we won't be getting into the details of it for our example, the dataset even has attributes on weekly game updates, team lineup, and detailed match events. We will use these datasets to demonstrate the basic steps of the process we take for such data science projects and use the dataset for three main goals: form meaningful player groups, discover other players that are similar to your favorite athlete, and form strong teams by using analytics. Since we are looking for questions to solve in data science, we can formulate a question around these goals. For example, I would instead say, how do I form meaningful player groups to find players similar to my favorite player? Finally, how do I use this information to form strong teams? To go even further, we need to ask ourselves, why do I want to know about strong teams, or what is the benefits of using analytics? In fact, one of the most critical questions you can ask yourself is, why am I doing data science in this problem? What insights do I expect? The question will lead you to find what you're looking for, and you can design strategies in alignment with your goals. Our goal is to take the data and generate insights from it that we can use to take data-driven actions. We call these insights actionable insights, which are very valuable, and they require knowledge of the subject area or business domain. For the soccer scenario, the insights we are trying to generate are related to better understanding of player strengths, performance enhancement, and attributes of a player's performance. We can turn this into a question saying, I want to find the quickest way to improve my favorite player's performance. How do I know what traits impact a player's performance more than the others? The coach can then take these insights and take actions to design programs that build upon these insights to improve team strengths. So how do we go about taking the steps to go from data to those most coveted insights? There are 5 key steps in the overall process of data science, namely data acquisition, data preparation, data analysis, presentation, and reporting of insights, and turning these insights into data-driven actions. In our soccer example, the acquire involves downloading the dataset or importing it to your data science. Acquisition step leads into data exploration and visualization and other data preparation. We then analyze the prepared dataset using statistical analysis and machine learning. Findings from these analyses are typically turned into reports and present it to the stakeholders who need to take actions. Using such insights, the stakeholders will go and take their actions and use them. In general, as we go through the examples, you will notice there are similar steps in any data science project. Much like the steps you take when you drive to the grocery store from your home, pick the keys, open the door, take a form of transport, car, bus, cycle, move, arrive, park if needed, etc. The specifics of each step can be different, but the overall process remains more or less the same. We will look into the data science process as a generalizable activity the rest of this week. But let's first continue to look at these steps in the light of the soccer data analysis example. As a first step in any data science activity, we need to consider that data can come from many different sources. This diversity of data sources will only continue to grow as more innovations are made. The broad categories include relational and NoSQL databases, text files in various data formats, and live online streams coming from machines, sensors, and online activities. In our soccer example, the provider of the dataset gathered the data scattered across many internet sites and did a thorough data collection and processing to make the data ready for analysis. The dataset includes structured data on scores, lineup, team formation, and events, as well as data on betting odds and players and teams' attributes. All we had to do in this case was to take that dataset and ingest it into Python. Data ingestion will be one of our focus areas in this course. Python has well-defined methods for ingesting data from diverse resources. These sources include various databases, data access APIs like the Twitter API, text files, and sensors data streams. By the end of this course, you will know how to efficiently utilize each of these data sources. The next step of our data science process is exploring the dataset. Python has libraries that can assist you in the data preparation phase when you want to explore your datasets. For example, with just one line of command, as you see here, you can generate vital statistical summary of your datasets like mean and standard deviation. The data preparation also involves data cleaning, as there are many challenges in real-world datasets. The cleaning can also build on the statistical analysis like removing outliers, missing values, or in general, weeding out unwanted stuff from your data. Although sometimes removing the unwanted entries can be a quick solution, sometimes it can still be a challenge to decide what to remove. In those situations, you can impute those fields with known aggregate values, such as mean of the columns, etc. Python offers data cleaning functions to help with general data cleaning tasks like finding and removing null values. In the example notebook on soccer data analysis, we share some examples to get started with, but we will point out to those functions as we go through our case studies throughout this course. In each step of the data science process, data visualization is an effective way to capture your team's attention and convey your message in a minimal time. Python has several open source data visualization libraries that can make this task much easier for us. We have a dedicated visualization section in the upcoming weeks. Analysis is the crux of the matter in data science. Once the basic preparatory steps are completed, you get to the algorithms. Although the third course in our MicroMasters will take you for a ride through these algorithms, in this first course, we will introduce you to some of them. There are three key categories: supervised learning, unsupervised learning, and semi-supervised learning. There are a vast number of algorithms and techniques as seen in this diagram for dimensionality reduction, clustering, and regression, for example. The scikit-learn library in Python provides many tools for machine learning in Python. We will introduce some of these tools to you as a part of this first course. Here, we start giving you examples of using some of these tools as a part of the soccer data analysis and our upcoming case studies. As a part of this example, we do feature selection. Feature selection is about selecting attributes that have the greatest impact towards the problem you are solving. It requires some domain knowledge to narrow down the number of features. For example, in the soccer use case, if you're trying to predict a player's performance, what are the most critical attributes? Blue attributes on agility, reaction time, shot power, and sprint speed? Or green attributes on hairstyle or movie preferences? Similarly, if you're grouping players into different sets, what attributes would you choose to assign these groupings to create complex features? Narrowing the features has several benefits. You get models that are easier to interpret, models get trained much faster, and you're likely to generalize well to newer scenarios. You will find almost every top machine learning algorithm already implemented in Python. Different functionalities are organized into libraries in Python, like scikit-learn, containing implementations of fundamental machine learning algorithms. In the soccer example, we will utilize a form of clustering algorithm called k-means from sklearn. Clustering means grouping your players into similar, meaningful sets based on those attributes you just decided. The idea of this slide is to show you how quickly and concisely you can call subroutines in Python that do exactly what you want to do. We import the right library in Python for k-means, and then we use the library to analyze our data. Notice how clustering is performed here in just one line. Don't worry about the details of these methods yet. Although it requires further expertise and understanding to pick the right tool for your analysis, this course will start a foundation for you to build up on in the coming courses. Now let's go back to the data science process we were following for our soccer case study. At this point, we are done with clustering. This means we have grouped players into meaningful groups based on the attributes we chose. Next, we will start interpreting the results. So how do we analyze the results? Something to consider are: do all of them have the same number of players? When we look at the attributes we had selected, how do these groups differ? Plotting these clusters might help with interpreting and presenting these results. The graph here helps us with both. Once we have done all the work of data cleaning, analyzing, and interpretation, it's time to present our findings. A big part of the presentation or reporting is explaining how we interpreted these results. Look at the graph and think of the 4 lines as signatures of each of the 4 clusters our k-means algorithm has found based on the features shown in the x-axis of this plot. Do any of the groups have exactly the same signature? The answer is no. Each group is unique in the sense that it differs from the other 3 in at least one attribute. To act upon such findings, team coaches can use this information to design customized improvement strategies for each group. There are many techniques and best practices for presentation or visualization of these results. We need to decide on the graph type, find a library or write our own, have enough details for the picture to be self-explanatory, like adding label axes, legends, and a readable font size. To summarize, we just explained a soccer data analysis case study and how we used a 5-step data science process to generate insights from our original dataset. The process involved in acquiring results, data preparation, analysis, and reporting of results can then be used for data-driven actions. We explained why actionable insights are the expected product of any data science project and the importance of using data and domain knowledge to generate questions that we can answer through data science. We also discussed some of the tools Python provides for data science. As a part of this week's materials, we give you a full Jupyter notebook that shows our soccer data analysis example. By the end of this course, you will be able to create similar notebooks of your own for simple data analysis tasks. Next, we will generalize this process for any data science problem before we start diving into the details of Unix and Python scripting.